Hi guys, this is part 2 of lesson 6, and we're really going to talk about in this part of the lesson about the inverse properties. So at its simplest, I just want you to know that whenever you have a logarithm with a base that's the same base as another exponent, those are going to cancel each other out because they're inverses. And so what you're going to be left with is just this up here, 2x. And I want to show you, we've actually done this before, but you just didn't know you were doing it. So I want to go way back up here, the very, very beginning, when we were talking about these. So let's kind of review what we learned. Remember that log, we learned that it was, when you have just a log, that's log base 10. And so notice that if the base and this base was the same, you just end up with the exponent. So all of these were log base 10, and the base of the exponent was 10. So it was just the exponent itself for your answer. And these show up on ACTs and other standardized tests, and they're really easy. So notice that you've got a base of an exponent and the base here. That's super small, but that's another 8. Let me see if I can make this a little bit bigger. Hold on a second. So you can't see it, but this is an 8 here. So these are the same. So then our answer is just simply x. So in this case, it's just what's next to the log. Okay, so I want to kind of look at this one a little bit differently. So I have 3 to some power equals 27 to the x power. So what if I kept these the same base? So 3 to what power equals 27? So that is going to be 3 to the 3rd power equals like that. So do you see how these bases are now the same? So because they're the same, I know that this is equal, it's just x. That's it. So let's look at this another way. So I want these to be the same. So in other words, log base 3 of 3 to some power times x. So, well, first of all, we have to figure out what that is. And so we just learned that 3 to the 3rd power is 27. So I'm going to rewrite this as log base 3 of 3 to the 3rd power times x. Okay, well, notice that these two are both the exponent. So our exponent is 3x. So our final answer for this problem is going to be 3x. So that one's a little tricky, but the goal is, let me do this in a different color, to get those bases the same. So let's do the same thing for this one here. So log base 2 of 2 to some power all to the x power. So we want 2 to what power equals 64? And so that's going to be 6. So I have log base 2 of 2 to the 6th power times x. I'm sorry, raised to the exponent of x. So don't forget, when you raise a power to a power, you multiply them together. So our answer is going to be 6x. Okay, so this one, just like the bases are the same here, don't forget that the natural log has a base of e. So these are the exact same type of problem. So our answer is going to be 20. Okay, so this one is just very similar to that one. So I want to, let's do it in a different color. I want to make sure this 3 should be a subscript 3. It didn't turn out that way. It doesn't look like it anyway. So I want it to be like that. So 3 to some power raised to the x power. So I'm really interested in 3 to what power equals 1 over 27? Well, I know that it's going to be negative because it's a fraction, and 3 to the third power equals 27. So I know, let's rewrite this. Log base 3, 3 to the negative 3 power, raised to the x power. So I know my answer for this one is going to be negative 3x. Okay, so we are going to find that same, we're going to do the same process that we've talked about with inverses in the past. So remember, to do the inverse, you're going to switch the x and y. In this case, we're going to write it in exponential form because exponential form is the inverse of logarithms. And then we're going to solve for y. Wow, I did not give you guys very much space on here, did I? Okay, so let's look at this one. So I'm going to write, first of all, I'm going to switch this. So this is going to be x, and this is going to be y. Then my next step, I'm going to flip it into exponential form. So 5 to the x power, because remember logarithms are always set equal to the exponents, equals y. And that's all you have to do there. Okay, this one is kind of sneaky snake because this tells me that it has a base of e. So remember on the last lesson up here, I told you that it's important to know that ln, that natural log, has a base of e, and log has a base of 10. So this is going to come into play on these. Okay, so the first thing I want to do is I want to change this to x and this to y, and then we're going to put it into exponential form. So let's walk through this slowly. So e is our base, e to what power? X equals y. And I'm done. Okay, so what I want you to do is try this one, and then we'll go the other way on these down here. Never mind, I'm a dork. This is exponential, so we're going to have to do this as a log. So these down here, go ahead and skip to these, and we'll come back to that one. Okay, so we're going to go ahead and skip that one. We'll come back to it in a second. So this one, all of these down here, they just have an extra step to it. So hopefully you were able to see that. So when I did this step, I had to get the y by itself. So I just multiplied this side by 2, and I ended up with 2 times 10 to the x power. This one, I had to subtract 2 here to get the y by itself. And so I had 6 to the x power minus 2. And then for this one, I had to divide by 9. And so I left it like this. So you can't simplify this because follow order of operations. You have to do exponents before you do division. So you can just keep it like that. Okay, so let's go up to this one. So this one is in exponential form. We've got to go backwards. So we have to do put it in logarithmic form. So I switched to x and y already. So I'm going to say log base. So what's our base? Our base is 5. Log base 5 of x equals y. And that's all you have to do. Okay, so we are at the end of this lesson, and you're able to do your assignment now.